Exponential and logarithmic equations. Suppose you were given 5 to the x equals 10. That is 5 to what power equals 10? You're not easily going to see that. So what you do is you take log of both sides. You take log of both sides. The reason I'm going to use log is because the right side will then just be 1. Because log of 10 is 1. If these are the same, you get 1. And on the left side, the reason I took log was so I can bring the power down. Well, this is x times log 5, or log 5 times x. If you had 3x equal 1, well then you would say x is 1/3. If you had x times 3 equals 1, you would say x is 1/3. That's like the 3. This is 1 over log 5. That is what x equals. That is, if you take 5 and you raise it to 1 over log of 5 power, you will get 10. It's hard to believe, but that is what you would get. So here, it was friendly to take log. For example, I could have done the same problem taking ln of both sides. I have ln of 5 to the x is ln of 10, and the x comes in front. Now instead of having 1 over here, like I did over here, I have ln of 10. And I divide both sides by ln 5. And there's your answer. These two answers are equal. Those two answers are the same. Calculate them. Convince yourself they're the same. Then try to convince yourself why they're the same. Now, if you have 10 to the negative x is equal to 2, well, I don't know what to raise 10 to get 2. So I will definitely use log this time. Log base 10. The reason is the left side is just negative x. Because this comes down as negative x times this, which is 1, equals log 2. So x is negative log 2. If two quantities are equal, this is understood to have a plus in front. If I change this sign, well then I have to change that sign, and they'll still be equal. 7 equals 7, and negative 7 equals negative 7. If two quantities are equal, if I change their signs, they'll still be equal. And the reason I wanted to change the sign is because I don't want to know what negative x equals. I want to know what x equals. So x is equal to negative log 2, which, by the way, that's the same as negative 1 log 2, which is the same as log 2 to the negative 1, which is log of a half. So you can either say x is negative log 2 or x is log of 1/2. Either one is perfectly fine. Now, If you have e to the x is 5, if you take ln of both sides, well then this is just x. X is ln of 5. And that problem is quickly done. If you have e to the 2x minus 1 is 100, you take ln of both sides. And the left side just equals the power. Because remember, ln is shorthand for log base e of e. That's 1. The power comes in front. You get the power times 1, which is just the power. Now that's a number. Don't let it bother you. Add 1 to it. And you get 2x's. Please don't say ln of 101. It's 1 plus ln of 100. Divide by 2, you get 1 plus ln of 100 divided by 2. That's what goes in for x. If you replaced x with that exponent, with that value, e to the 2x minus 1 will equal to 100. It's like magic. Now, here's a nice problem. These two bases are different and they don't share any common factor. In other words, if you had 8 to the x is equal to 4 to the 2x, well, I can write 8 as 2 cubed and I can write 2 as 2 squared. So you have 2 to the 3x is equal to 2 to the 4x. Let's say plus 1, please. So then you would say 3x plus 3 is equal to 4x. So that should be x, because 3x plus x equals 4x. That's the value of x. But we can't do that in our case. 2 and 3, I can't write 2 nor 3 using the same power. Okay. So what I'm going to do is I'm going to take log or ln of both sides. The power comes in front equals log of 3. The power comes in front. So distributing, we have 3 log 2x plus log 2. On the right side, we have log base 3x minus log 3. Let's bring all the x's to the right side. So on the right side, we have log 3 x's minus 3 log 2 x's. That's how many logs x's we have on the right side. Bringing this to the left, we have log base 2 plus log 3. So the left side is log 6. And the right side, well, that's log 3 minus log 8, because 2 to the third power is 8. And what we get is log base 6 divided by log base 3 minus log base 8. That's x. You could write the denominator as log of 3/8. I just prefer not to have a fraction in the denominator. It's a matter of taste. This answer and this answer are both valid, unless your teacher says write your answer using as few logs as you can. Here I have 1, 2, 3 logs. Here I only wrote log twice. If that's what your teacher says, then that should be the way you write your answer. And that is the answer to that problem. Now, suppose you have x squared 2 to the x minus 2 to the x equals 0. So 2 to the x. Now, how many 2 to the x's do we have? Well, we have x squared minus one of them. 2 to the x. I factored out 2 to the x. So either x squared minus 1 is 0 or 2 to the x is 0. But that's never. 2 to a power is never 0. So here x squared could be 1, which means x is plus or minus 1. So if you plugged in plus or minus 1 in here, both sides would be equal. In this case, they both equal 0. And that makes sense, because if you square 1 or negative 1, you're going to get 1. And 1 times 2 to the x is 2 to the x. And then if you take away 2 to the x, you'll have 0. If this is 1, then yeah, that's going to be 0. 1 times 2 to the x minus 2 to the x is 0. Okay, 2 to the x itself will never be 0. Suppose you were asked to solve this problem. For x. Well, x is in the denominator. What I would do first is take reciprocals. That way, what I want is in the numerator. 10 times this equals the top. 10 times a half, or half of 10 is 5. So the numerator must be 5. And after all, 5 over 10 really is a half. The top has to be 5. So this has to be 4. This 1 plus 4 is 5. So e to the negative x must be 4. If I take ln of both sides, the left side is just negative x, because the power comes in front, so you have negative x times the ln of e. But ln of e is 1. Log base e of e is 1. If these are the same, it's going to be 1. Why? Because whether it's e or some other value, this number raised to the first power will give me back itself. So it's 1. And the right side is ln 4. Change the signs, and we get x is negative ln of 4. And that is the answer to that problem. Now, suppose you wanted to solve e to the 4x plus 4e to the 2x minus 21 is 0. Well, this is a quadratic equation. If I let u equal e to the 2x, if I square both sides, the left side will be u squared, and the right side will be e to the 4x. So rewriting this using u's e to the 4x, I write u squared. E to the 4x plus 4 e to the 2x, which is u, minus 21 is 0. Two numbers that multiply out to negative 21 but add up to 4. Negative 21. 1 and negative 21. Let's say negative 1 and 21. Negative 3 and 7. There it is. This is u minus 3 times u plus 7. So either u is 3 or u is negative 7. U is e to the 2x. So either e to the 2x equals 3 or e to the 2x is negative 7. And this is never. E to no power is negative. If I take ln of both sides correctly, if I take ln of both sides, the left side is 2x and the right side is ln 3. Dividing by 2, x is 1/2 ln 3. You can write it as ln 3 over 3, or you can write it as ln square root of 3, or you can keep it this way. These are all fine representation of the same answer. If you have ln of x is 10, this is very easy. This means log base e of x is 10, so e to the 10 is x. E to the 10 is x. And I found out what x equals. It's e to the 10. Likewise, if I told you log x is 3, remember there's an understood 10 there. So 10 cubed, 1,000, is equal to x. So that one is done. Now, if I tell you log of 4x minus 1 is 2, remember there's a 10 there. 10 squared is equal to 4x minus 1. So that should be 101. Because when I take away 1, I get 100. So 4x is 101, and x is 101 divided by 4. ln of 3x plus 4 is equal to 1. Well, you should know that ln of e is 1. But if you forgot, remember there's an e there. E to the 1, which is e, is equal to 3x plus 4. Like I said, 3x plus 4 has to be e. So 3x taken away 4 from both sides is e minus 4. And now I divide both sides by 3. X is equal to 3x, e minus 4 divided by 3. Log base 2 of x squared minus x minus 2 is 2. 2 squared, which is 4, is equal to that. So that is equal to 4. So x squared minus x minus 6 is 0. I take away 4 from both sides. Well, this gives me x minus 3 times x plus 2 is 0. So either x is 3 or x is negative 2. you should make sure that it makes this positive, these answers. 3 squared is 9, take away 3 is 6, take away 2 more is 4, which is positive. Negative 2. Negative 2 squared is 4, minus the negative 2 is 6, minus 2 more is back to 4, which is positive. So those two answers stay. Let's suppose you have 2 log x is equal to log 2 plus log 3x minus 4. Well, the left side is log of x squared, because the 2 can come up as the power. And the right side is log of 2 times 3x minus 4. Log a plus log b is log ab. Now log is a one-to-one function. That is, the only way you can hit that value is by taking log of that number. The only way you can hit that value is by taking log of this. Unlike if you have x squared. There are a couple of ways of getting this value. You can square that number, or you can square that number. That is, if f of x is equal to x squared, f of 2 can equal f of negative 2. These are not the same. But when it comes to log, if you learn that log a is equal to log b, then a does equal b. Because you can't take log of 2 different values and get the same answer. Because it's always going up, and away. It's not going up and down. If it did that, then I can hit, let me remove this please. I can hit a particular y value. I can say hit this y value by taking log of this number and taking log of that number. I can take log of A and log of B and get the same answer. But logs don't do that. It doesn't come back down. Like I said, it just goes up, and away. Fair enough. It goes, first it was going up quickly and it's slowing down. But it's getting there. You can only take log, if log of A equals log of B. If log of this equals log of that, this must equal to that. So x squared is 6x minus 8. That is x squared minus 6x plus 8 is 0. X minus 4 times x minus 2 is 0. Those two numbers multiply out to positive 8, negative 4 and negative 2, and they add up to negative 6. So, either x is 4 or x is 2. You have to be careful. When x is 4, that would be 4, that would be 2, and this will be 12 minus 4, which is 8. It'll be positive. So 4 stays. What about 2? Well, this will be 2, and this will be 2, and this will be 6 minus 4, which is also 2. Which makes sense. 2 log 2 is equal to log 2 plus another log 2. You add this together, you get 2 log 2s. But most importantly, none of these x values made these arguments not positive. So we keep those 2 answers. You have to check that. Suppose you come to learn that log base 2 of 3 plus log base 2 of x is equal to log base 2 of 5 plus log base 2 of x minus 2. Well, the left side is log base 2 of 3x, because log a plus log b is log ab, same base, equal same argument on the right side. Log a plus log b is log a minus b. If log of this is equal to log of that, then this is equal to that. The right side is 5x minus 10. This must be 2x's. That must be 2x's, because 5x minus 2x is 3x. If you don't believe that 2x is 10, watch this. I'll bring the 3x's to the right side. I'll bring the plus 10 to the left side. The left side is 10, and the right side is 2x. That is, 2x equals 10. So x is 5. That is a possible answer. When x is 5, this is 3. When x is 5, this is 5. When x is 5, this is 5. When x is 5, this is 3. I never said a non-positive value. I said 3, 5, 5, and 3. Those are all positive values. So x equals 5 gets to stay as the answer. Solve for x. Log x plus log x minus 1 is equal to log of 4x. So the left side is log of x times x minus 1, because log a plus log b is log ab. And this equals to log 4x. Well, if log of a equals log of b, then a and b are the same. Now, there's two ways of doing this. We can divide both sides by x, but realize that x equals 0 is the solution. 0 times, if x is 0, 0 times whatever this is will be 0, and 4 times 0 is 0. So we know x equals 0 is the solution. Now when we divide by x, we get x minus 1 equals 4. Oh, 5 minus 1 is 4. X is 5. Or we could have distributed. You get x squared minus x is equal to 4x. X squared minus 5x is 0. Factor out the x. You get x minus 5. So either x is 0 or x is 5. Now, if x is 5, this will be 5, this will be 4, and this will be 20. All positive values. All positive values. Well, if x is 0, this will be 0. You can stop right there. Or 0 minus 1 is negative 1. You can stop there. Or if you want to check this first, 4 times 0 is 0. You can only take log of positive values. So we have to reject x equals 0. So the solution is just x equals 5. X equals 5. You can get erroneous answers. Suppose you have log x plus log x minus 3 is equal to 1. Now, there's two ways of doing this. This is log a plus log b, so it's log of ab. equal to 1. Now, there's an understood 10 there, and you can say 10 to the 1 is equal to x times x minus 3. Or, you can realize that 1 is log 10 itself. 1 is log 10. So this equals 10. That is what I have down here. Now, what you can do is, this is some number times 3 less should equal to 10. Well, 10 times 3 less, that's not 10. 9 times 3 less, that's not 10. 8 times 5 is 40. 7 times 4 is 28. 6 times 3 is 18. Ooh, 5 times 2 is 10. So x can be 5, or x minus 3 would be 2. That's one answer. Or x can be negative 2, and x minus 3 would be negative 5. And this product is also 10. So either x is 5 or x is negative 2. Of course, you could FOIL out, and then you get x squared minus 3x minus 10 is 0. And I was looking for two numbers that multiplied out to 10 that differed by 3. Now, I want to know two numbers that multiply out to 10, but add up to negative 3. It's a very similar question. The answer is negative 5 and plus 2. So, either x is 5 or x is negative 2. Let's try 5. Well, that will be positive. It will be 5, and this will be 2. 5 minus 3 is 2. So 5 stays. Well, when x is negative 2, that will be negative 2. And you can't take log of negative numbers. So you reject it. Please don't think just because x is negative, they have to be rejected. That's not true. That is not true. If you have log of negative x plus, say, log of x plus 5, let's say that it turned out that these were the two answers. Well, if x is 5, well then fine, this will be 10, but this will be negative 5. We have to reject the 5. But then negative 2 would be fine. Negative 2 plus 5 is 3, and negative 2 will be 2. So in this case, the 5 would go, and the negative 2 would stay. Now, I want to practice at least one more problem, like solving it the same way we solved x times x minus 3 equals 10. What if you had x times x minus 2 is equal to 80? This number is 2 less than that number. Oh! 10 times 8 is 80, and that's 2 less. Or, negative 8, 2 less would be negative 10. These are the two answers. X is 10, x is negative 8. Now, if you FOIL this out, well, first of all, that takes time. You get x squared minus 2x, x squared minus 2x, and you bring the 80 over, equals 0. Now, I want two numbers. For the record, I'm already done. Okay, now I start my question. I want two numbers that multiply out to 80, but add up to -2. Over here, I wanted two numbers that multiplied out to +80, but differed by 2. I want the numbers to differ by 2. It's a very, very similar question. And the rate of difficulty of the answer to those two questions are the same. Finding two numbers that differ by 2 that multiply out to 80 versus finding two numbers that multiply out to -80 and add up to -2, the same rate of difficulty. The thing is that I had a lot of work to do just to get to that statement. I had to distribute the x, I had to bring the 80 over. Fine, it wasn't rocket science doing that, but it was an extra step. Two numbers that multiply out to -80 and add up to -2 are -10 and +2. So x is 10 or x is -2. +8, excuse me. +8. X +8. -10 and +8 multiply out to -80 and add up to -2. But I had those two numbers long time ago. Let's try one more. This is 28. Want two numbers. This is 3 less than the other number, but they multiply out to 28. 7 and 4. 7 and 4. Those are the only two numbers that I know that multiply out to 28. I mean, I guess 14 and 2 also multiply out to 28. But this number is 3 less than that number. Or -4 and -7. X can be those numbers. Now, to do it the way you were taught, you have to distribute. You have to bring the 28 over. Depending upon how good you are with that, you may first get x squared minus 3x is 28, and then write that you're taking away 28 from both sides. But eventually you get this. Then you ask yourself, for two numbers that multiply out to -28, but add up to -3. The answers are -7 and +4. X equals 7, x equals -4. Do not file this out. I don't think it's beneficial. Now, having said that, if there are no integers that you can think of that multiply out to 28, maybe the problem was 29. Suppose the problem was 29. So when you bring the 29 over to the left side of the equal sign, you're going to have -29. And you're not going to know two numbers that multiply out to -29 and add up to -3. So now you'd have to use the quadratic formula, which you couldn't do from here. But you would try to see if you can come up with two numbers that multiply out to -29 and add up to -3. Well, Again, if you can't, you really have to do this. But over here, we can find out as well, without even doing this, if there's going to be an answer. And if there was an answer, like when it was 28, we're done. If we couldn't find an answer, then when we come here, we won't try. We spent a few seconds here trying and we couldn't come up with a combination, so we won't spend that time here. We'll go right to completing the square or using the quadratic formula, what have you. We won't try to say, oh, let's see if I can factor it now. No, you can't. If you couldn't find the two numbers over here, you're not going to find the two numbers that go here. They're the same rate of difficulty. Okay, don't FOIL out. I hope you like that. But let's finish this up with one more problem, please. Suppose you have log base 2 or something, don't worry about what that something looks like, equals 2. I don't care what this is. It equals 2 squared. Log base 2 of x is equal to 4. Okay? Doesn't matter what this equals. Oops. If I call this x plus 1, it has to equal 4. If I called it x plus 4, 2 squared, 4, has to equal this. If I called it 2x plus 4, 2 squared, which is 4, equals 2x plus 4. What's ever in here is 4. And if what's in here is log base 2 of x, whatever, 2 to the 4th is equal to x. And I know what 2 to the 4th is. It's 16. And we should make sure of something. I'm taking log of two things. Taking log of x, log of 16 is okay. And then I'm taking log of this. But it says so right here. This is 4. So I'm taking log of 4. That's okay. Taking log of two things. Here, I'm taking log of x, and x is positive. And here, I'm taking log of this. But it says log base 2 of x is 4. So if this is 4, that's okay. But then I'm taking log of 4. And I can take log of positive numbers. I just can't take log of 0 or negative numbers. So it turns out that x is equal to 16 and that this video is done.